Okay, so the situation we have now is that not every quadratic is given to us in vertex form. So we have standard polynomial form, we have factored form, but somehow we want to get to vertex form to see the vertex, which might be hard to see in this one right here. So that process is called completing the square when we want to get to vertex form. So I have my standard polynomial form, and what I'm going to do is group my x's. I have an x squared minus a 12x, and I'm going to leave a little space. And then I have my plus 37, and I'm going to put another space here as well to remind me of something. Now, my goal at this point is to get this piece in front to some quantity squared. So there's going to be this magic number that I place here so that when I factor it, it's going to be the same factor that I can absorb into just this quantity squared. So maybe you can guess and check to that, but eventually what we want to notice is that I'm looking for a number that has to add to negative 12. But it's going to have to be the same number. So if I think about that, well, this number here is going to be half of whatever b is. So this placement right there is always going to be half of b, but it's going to be the end of my expansion. So I'm going to take that last number times itself, and that's what's going to go right here. So I'm going to take half of b squared. So in this case, I have a negative 12, so half of that is going to be negative 6. I squared that, and I'm going to put a positive 36 there. But by putting a positive 36 there, I've really changed the quadratic quite a bit. So what I need to do then, just so it stays the same quadratic, is subtract 36. I have to keep the equation balanced. So by adding 36, subtracting 36, essentially I'm just adding 0. But again, what I wanted to do, or my goal was, I want these terms to absorb into a perfect square. And you can factor that if you want to go through your steps of factoring. But what's nice about it, if you put half of b squared right here, it should always just be x plus or minus whatever your b is. If you want to check, you can expand this, and it gives you these three terms. So then all I have to deal with next is this outside addition or subtraction. In this case, you have 37 minus 36, which is just a positive 1. So if this were a function, and I wanted to know where the vertex is, which we used from before, the vertex is at 6, 1. And I can find x-intercepts, y-intercepts the same way. And it's actually probably a little bit easier to find x-intercepts and y-intercepts from the vertex form.